Hey y'all, CB here, the No BS welder here at NBS Welding, and we're getting back on a job that we had worked on quite a while ago. Company's got this vac truck with an aluminum tank. It's leaked, and we've worked on it a few times, welding patches and welding up stuff in the bottom of it. Was thinking maybe that it was wore thin because the last time that I had to do a quick patch on it on the weekend, when I was trying to weld it, it was blowing out on me. It was making me think that it was going to need more work done on it, or it was going to go back to leaking again. And I had talked to the company at that time, and they said they had a new truck coming, and when they got the new truck, they'd bring me this one to do some more work on it and try to make it last. The tank, since I patched it the last time, it hasn't started leaking yet, but they did get their new truck, and their driver is running the new truck. So that gives us a little time to see if we can do a little bit better job working on this tank that we've had so much trouble with before. If we look down inside the tank, you can see it's got two major baffles in it to prevent the sloshing. So the baffles sort of separate the tank into three parts to a certain extent. And the very first part near the cab is the one where we've had the most trouble. I'm going to get the truck fired up here and get the PTO engaged. And the beautiful thing about this truck is it's got a dump system on the tank, which has made it very much easier to work on than if it had not had such a system. So I'm going to get it raised up, and obviously when we're getting under it, we're not going to be counting on the hydraulic cylinder to hold it up. So the first thing I generally do is I'll get some really tough treated lumber or steel and slide underneath the back of it. And then the next thing is I get something like a jack stand, and I'll put that more in the middle as something to just make sure we're holding it up with something besides just the hydraulic cylinder. So right here on this area where I've put patches on patches to get them by for so long, I'm going to be cutting a section out and really investigating what the heck's going on here. And the first thing I do is I'm going to get a really aggressive power brush and clean this aluminum up in an area right outside of where I've done so many patches. And I'm going to use I'm using electrical tape here to lay out where I'm going to cut. This cut doesn't really have to be perfectly square or anything perfect with regards to size or shape. I'm going to just lay it out with electrical tape and kind of eyeball it and cut it out where it looks good. The first tool that I'm going to use getting started as far as cutting this out, I'm going to get out the death wheel. If you haven't seen it before, what I use to cut and grind aluminum, in a lot of cases, it's actually a 5 3/8 inch metal cutting saw blade that I run on a low RPM rotary grinder. It's a very dangerous tool. I don't recommend anybody use it. If this blade hits you, you're going to the hospital. I use it as little as possible, but to cut and grind aluminum in certain situations, it works the best, and I use it. What I'm using it for here is just to make the initial slot that I need in order to get a Sawzall blade in there, and then I'll do the rest of the cutting with a Sawzall, which is a lot safer. Once I've got that slot made with the death wheel, I'm using a wood blade. I use woodworking tools on aluminum quite often. Circular saw, all different sorts of woodworking tools. They work well on aluminum. And you can see that the aluminum chips were really tearing me up working overhead like this. So I went and got a welding shirt and put on, and a face shield, and that helped quite a bit. And then I've gone ahead. I go ahead and get this section cut out so I can find out what's going on. And then I'll use the plasma and I'll just arc gouge all of my patches off of it and inspect and see what we got. Now, one thing I found in here that I didn't expect to find so much of was just iron ore, just like basically rust is what I'm pulling out of there. And I found out that really is the bulk of the problem here, because the problem, I had thought that the big problem we were having with these leaks was because this section of the tank straight across from where the vac blower blows into the tank had worn it thin, and that's not actually the case. The leaking that we had is a result of galvanic corrosion and pitted areas where the aluminum is severely pitted from corrosion, and I think that corrosion occurred because of this rust that's inside of the tank. When you have rust like inside of this tank, which is iron ore, it's the when steel corrodes or when aluminum corrodes, it's just returning to its original state. You know, steel will turn back into iron ore that it was originally, you know, made from, and aluminum will turn back into, you know, aluminum oxide that it was originally made from. The rust that's inside of this tank most likely has come from materials, water, oil, or anything that the truck has hauled over the years that had rust in it, rust from pipes or rust from wells. But we got this piece out of here. I got all of the patches cut off. I use a lot of different tools, including my favorite sanding pad. I use a 5-inch sanding pad, and I treat my sanding pad. When I work aluminum, I treat my sanding pad with beeswax to keep it from galling up, and clean this part up, and we're ready to move on to the next part of this. Gotta hit y'all up real quick with a t-shirt ad. Boss Lady Tina's selling these t-shirts. Got NBS welding on the chest, American flag on the sleeve, great big NBS welding on the back. Send Tina an email request, nbswelding@aol.com, $25 plus the cost of shipping. Thank you. Taking a look here from the inside of the tank, we want to I scraped at this rust. I scraped and scraped, and it was really hard in the beginning. I had a putty knife and different things I was trying, and I got it scraped away. And then I found out when you get it wet, it really moves a lot easier. And I'm really glad that I went and got the water hose and tried it. It still took a minute to get it all out of the tank, but the water hose worked better than anything I tried as far as just getting that stuff out of my way. And here's a really good look after I had sprayed. This is a really good look at some of that really deep galvanic corrosion pitting that's just pretty much eating holes in the bottom of this tank. So this is what we got to decide how we're going to fix. When I cut that patch out, I was expecting to be cutting out a piece that all in all was very thin and wore away and lightweight, and that wasn't the case at all. A whole lot of that patch is just as thick as the day it was made, except for where the pitting is at. So I tried a wire brush at first, and that didn't work. And then I switched to my one of my burr bits that I use for aluminum, and I just pretty much tested the concept of burr bitting into these deep damaged pits of corrosion and trying to weld it up with a aluminum MIG welder. And it worked what I felt like pretty quick. If I'm looking at the amount of pitting that I'm going to weld up here and comparing that to trying to fit a patch or a series of patches into the tank, I decided that I could weld up and repair the pits faster than I could fit patches all throughout such a large area. And you know, like I'm saying, the areas just where this pitting and corrosion is taking place, that's the only places that need fixed. You know, the rest of the aluminum where it's not pitted is thick. So I ended up trying a few things. I did a video recently about a MIG welding aluminum with the ARCCAPTAIN 205MP and its pulse function on MIG welding and its ability to feed aluminum MIG wire through the standard gun just makes it absolutely the best aluminum MIG welder that I've run. The pulse function is a godsend on aluminum. You get all the benefits of running high voltage heat on aluminum without the negatives of melting through it. So it works great. And this is all the rust that was lined in the front, laying in the bottom of that tank. And you get galvanic corrosion from dissimilar metals. And here, you know, we've got rust that came out of steel from material that the tank is hauled, laying on aluminum, causing that kind of corrosion. So what we got here is where I've went inside of the tank with the burr bit and I've grinded out and cleaned out all of the areas that I want to fill with weld to fix the pitting and damage that is taking place from this corrosion. And as you can see, there's several places where just as a matter of cleaning it up, I've ground completely through it. And that's kind of a surprise that the tank wasn't leaking when they brought it to me this time, really. But it wasn't. It was holding. And that kind of gives you an idea that a tank like this could probably have some small seeping leaks and still not leak just because of small particles that could be probably stuck in little holes. So I've got the ARCCAPTAIN MIG205MP rigged up with argon gas and 045 solid MIG wire, set on the pulse function in order to do this aluminum repair. And we're going to go inside of it. We've already repaired the patch. Now we're going to go inside of the tank. So another ARCCAPTAIN product we're going to be testing is this W200 ARCCAPTAIN welding helmet. And this is the one that comes with the rechargeable LED light, which is obviously going to be a huge help in this scenario. And so we're going to get to test out this helmet with the light. And it really turned out to be just what I needed on this job. The Fitville is helping to support the NBS Welding YouTube channel by giving us products to test and endorse, and we get a commission if you decide to buy. You also get a discount. This is the steel core work boot with a composite toe. I've been beating the tar out of these things. This is the high top steel core work boot that feels like a sneaker. That's where the protection's at. I've been wearing those a lot more in the shop for the protection, although these are the Fitville Lug Max Outdoor that I was wearing in the shop, and they work. They don't have the composite toe. They don't offer the protection really for your feet, but the comfort is much, much more with the Fitville Lug Max Outdoor. That's a great shoe. These are the Fitville Jet Core running shoes. I've got 140 miles on these shoes. So this is about half life of a running shoe. You generally don't run more than 300 miles in a shoe before you replace them if you're a runner. These got 140 miles on them right now that I've ran in these shoes, and there's no sign of wear. The quality's got to be there, or you'd see this shoe falling apart. It's not. It's a good shoe. These are the Fitville windproof sunglasses. I wear these on my 5-mile runs. I run 5 miles in about 45 minutes, and these things stay put. They don't fog up. They're lightweight. They knock off the glare, but they're not too dark. So even early in the morning, it's no problem wearing these. There's a link in the description of my videos that'll take you to the Fitville website. If you buy any products and use the promo code CB28, you'll get 28% off, and that really helps with the NBS Welding YouTube channel. So I want to thank you. All right, so now we're inside of the tank. We want to weld the inside of this patch, and I've got to say, I really think this is the first time since I became an ARC Captain affiliate over 2 years ago that I'm doing something with the ARC Captain machine that I do not think I could have done with the equipment that I have. My Miller-Matic 252 that I used to MIG weld aluminum with a spool gun would not fit inside of this tank. And if I was holding that huge machine above the tank with my forklift, I don't think that the spool gun that I have would reach to where I have to get to weld this. So not only do I think here I'm in a situation where this super small and light MIG205MP ARC Captain fitting inside of this tank with me is a huge blessing, but I can't pulse MIG like this with my Miller either. The pulse MIG function is making this really nice, and also I'm feeding this aluminum wire. I'm feeding it through a standard gun, so I'm not having to hold up this huge nasty spool gun. So there's just a whole bunch going on here that I'm really thankful for ARC Captain for, and I'm also wearing the ARC Captain welding helmet while I'm doing it. So I'm just tickled all the way around and thankful to be able to get this done the way I'm getting it done. And I got it done, and climbing out of here, it all went real well, and now we're going to be doing some testing. So the final testing here is to set the vac machine on blow, and that will charge the tank with a pressurized air. And then the next step is to take this is a mixture of dish soap and water. Put quite a bit of dish soap, couple squirts in a spray bottle, and you know, just spray it all over, because with this contaminated aluminum, you know, your chances of having leaks or missing a spot or something, you just got to check. You know, you just got to check it out. And really, if it leaks this air and you get the air sealed, you probably got nothing to worry about as far as hauling water and oil like they haul, because if it's holding air, you know, it'll hold diesel fuel, which is diesel fuel and gasoline is really good for leaking. It leaks a lot easier than the dirty water or oil that they would normally haul in this. So if you got a tank like this sealed up where that thing won't leak air, then you're good. And I'm kind of fortunate for the video that I'm able to show you I found a leak. This is what it looks like. So I'm getting to show you. See these bubbles? This is what the dish soap does. And so here's a spot where I welded on the inside, and you can see it kind of warped the aluminum on the outside a little bit. But for some reason, probably due to contamination, it didn't get sealed all the way up. So we're going to have to add some weld here on the outside. See the bubbles? I'm not proud that this is leaking, but I'm just really happy that I get to show you what it looks like with the soapy water when it does leak. That's a fortunate thing for this particular video. So I rub on it with my sander and clean it up, and the next thing I'll do is I'll hit it with the soap again, and just to make sure I know exactly where, because I would like my my leak to be right in the center of my sanded spot. That way when I start welding, I'll just probably weld around in a circle, starting in the place that I cleaned, and kind of do like a plug weld motion until I've got it filled in really well.